Welcome to the DIY Honda Garage channel. The DTC P0502 indicates a problem within the continuous variable transmission CVT speed sensor circuit, specifically an open or short condition. This sensor plays a critical role in monitoring the speed of the transmission, sending vital information to the powertrain control module PCM for proper vehicle operation. The location of the CVT speed sensor is integrated within the transmission assembly, generally situated near the output shaft. A malfunction in this circuit can lead to inaccurate speed readings, which may affect the vehicle's performance and overall drivability. It's important to recognize that this issue is directly related to electrical problems, rather than any mechanical failures within the transmission itself. Moreover, diagnosing and repairing this error is crucial to ensure that the vehicle operates efficiently and safely. DTC P0502 refers to an open or short conditions within the CVT speed sensor circuit. This sensor is essential for conveying the transmission speed to the PCM, which adjusts various aspects of the engine and transmission performance. The CVT speed sensor is usually situated in the transmission assembly, typically close to the output shaft, where it can effectively measure rotational speed. Proper functioning of this sensor is crucial, as inaccuracies can lead to poor vehicle performance, idle issues, or potential engine damage. As indicated, diagnosing and fixing electrical issues is fundamental here, as mechanical problems are not the source of this DTC. Therefore, attention should be directed towards the wiring and electrical connections associated with the sensor. The possible causes of DTC P0502 can stem from various electrical anomalies within the circuit. Wiring issues are one of the primary culprits. This encompasses open or short circuits, which can disrupt the signal flow from the CVT speed sensor to the PCM. Poor connections play a critical role as well. Loose terminals or degraded connectors may fail to transmit the necessary electrical signals. Moreover, a faulty CVT speed sensor could also trigger this DTC, indicating that the sensor may need to be replaced. Understanding these causes aids in narrowing down where the problem lies, facilitating a more efficient troubleshooting process. It highlights the importance of meticulously checking electrical components before replacing sensors to avoid unnecessary expenses and repairs. Symptoms associated with DTC P0502 typically arise from the disruption in speed signal transmission. Engine performance issues may manifest, causing the vehicle to behave erratically during acceleration or deceleration. Additionally, you may encounter erratic speedometer readings. The speed displayed may become inconsistent, leading to driver confusion. Stalling could potentially occur in extreme cases due to improper communication between the CVT and the engine management system. These symptoms underline the necessity for prompt diagnosis and resolution to ensure vehicle safety and performance. Affected drivers might experience a significant impact in their driving experience, highlighting the importance of addressing this DTC swiftly. In the initial troubleshooting step for DTC P0502, begin by turning the vehicle to the on mode, which allows electrical systems to energize. Next, clear the DTC using the Honda Diagnostic System, HDS, to reset any error states in the PCM. Following the DTC clearance, turn the vehicle off and to the lock mode to stabilize the system. It ensures an accurate basis for further diagnostics, preventing erroneous data from affecting the troubleshooting process. This foundational step is essential in re-establishing a baseline from which further diagnostics can commence. It sets the stage for subsequent checks on vehicle speed and any potential fault reproducing conditions. In the second troubleshooting step, once the vehicle is turned off. Assess for any pending diagnostic trouble codes, DTCs, using the HDS. If the previously noted DTC P0502 reappears, it indicates a confirmed failure that duplicates the original error condition. In contrast, if no DTC is present, note that this may signify an intermittent issue where the system is currently functioning correctly. It is crucial to check for poor connections and loose terminals between the CVT speed sensor and the PCM at this stage. Intermittent failures can often stem from minor wiring faults that might not always manifest during tests, but can lead to high operational risks when ignored. Take a systematic approach to inspect and secure connections for reliability. During the third troubleshooting step, begin by checking the voltage between the designated test points while ensuring the vehicle is in the on mode and the CVT speed sensor's 3P connector is disconnected. Specifically, measure the voltage at test point 1, which corresponds to the number 3 terminal of the CVT speed sensor 3P connector, and test point 2, which should lead to body ground. What you are looking for here is an approximate voltage of 5 volts. This voltage confirms the power supply is reaching the sensor as intended. If the measurement indicates around 5 volts, proceed to the next step, verifying that the VCC2 wire is intact. However, if the voltage differs, it points to possible open wiring issues that require immediate attention. In this fourth step, again, measure the voltage between specific test points with the vehicle in on mode and the CVT speed sensor's 3P connector still disconnected. This time, focus on test point 1, which is the number 1 terminal of the CVT speed sensor 3P connector, and test point 2, which corresponds to the number 2 terminal of the same connector. As in previous tests, you should expect to find approximately 5 volts. This indicates the SG2 line is correctly functioning and suggests the wiring is intact. If the voltage reading falls short, it suggests an open condition in the SG2 wire, which then necessitates repairs between the CVT speed sensor and the PCM to restore proper function and communication in the circuit. For step 5, you will need to ensure the vehicle is in the off mode, and then proceed to jump the SCS line using the HDS. Disengage the PCM connector B51P for this step, while verifying the continuity between the test points. Continuity testing will take place between test point 1, the number 3 terminal of the CVT speed sensor connector, and test point 2, which is body ground, with the connector still disconnected. This test checks for any shorts in the VEL-DD wire leading to the PCM. A confirmed continuity indicates a short to ground in the VEL-DD line. Therefore, repair is vital. However, no continuity would suggest that the VEL-DD line is not shorted, leading to further troubleshooting steps. During step 6, the focus shifts to checking for continuity between designated test points. Once again, with the vehicle in off mode and the relevant connectors disconnected. Test point 1 being the number 3 terminal of the CVT speed sensor 3P connector, and test point 2 being the number 8 terminal of the PCM connector B51P. A successful continuity result confirms that the VEL-DD wire is functioning correctly. If so, you then have the option to update the PCM if there is outdated software, or consider substituting with a known good PCM as the next troubleshooting phase. If an update or substitution resolves the DTC P0502, then your issue is complete. However, if the VEL-DD wire has continuity and the troubleshooting still does not clear the DTC, further repairs to the wiring may be warranted to ensure reliable operation. In the final troubleshooting step, begin by ensuring all connectors are properly secured before turning the vehicle to the on mode. Following this, clear the DTC once again using the HDS to reset the diagnostic data stored in the PCM. After clearing the DTC, switch the vehicle to the off mode and enter the VSA, Vehicle Stability Assist, maintenance mode. Perform a test drive, aiming to achieve speeds of 37 miles per hour, 60 kilometers per hour, or more. Then allow the vehicle to decelerate and come to a stop. Post-test drive, utilize the HDS to check if DTC P0502 reappears. If it shows yes, the CVT speed sensor likely needs replacement. Conversely, if the code does not return, then the sensor is operational and should be updated or modified accordingly based on previously mentioned steps. After completing all necessary repairs, it is vital to conduct a final repair verification using the HDS to ensure that the DTC P0502 has been successfully cleared. This step involves rechecking the vehicle systems to confirm that no error codes reappear during the verification process. Additionally, it's crucial to observe the vehicle in normal operational conditions post-repair to ensure that no symptoms persist that could indicate an unresolved issue. This encompasses monitoring the speedometer readings and overall vehicle performance to validate the effectiveness of the repair measures taken. A clean DTC check and proper vehicle functionality affirm the success of the repair efforts, safeguarding the vehicle's reliability moving forward. To prevent the recurrence of issues associated with DTC P0502, it's essential to implement a regime of preventive maintenance. Regularly inspecting wiring connections for signs of wear, fraying, or corrosion will help minimize future risks of open or short-circuit conditions. Moreover, ensuring connector security, especially around the CVT speed sensor and PCM area, can significantly reduce the chances of intermittent electrical faults. Scheduling periodic system diagnostics can further preemptively identify any brewing issues before they escalate into more significant repair needs. Proper preventive care enhances the longevity of the vehicle's components, ensuring that they function as intended over time. Taking proactive measures can lead to more enjoyable and reliable driving experiences. In conclusion, understanding DTC P0502 is critical for addressing electrical issues within the CVT speed sensor circuit. By following the structured troubleshooting steps provided, vehicle technicians can effectively identify and repair underlying problems leading to this trouble code. A detailed understanding of possible causes, symptoms, and electrical testing methodologies paves the way for rapid issue resolution. Furthermore, implementing preventive measures enhances the vehicle's reliability, prolonging its operational lifespan. It is crucial to recognize the signs of potential issues early, allowing for timely interventions that keep your Honda HRV functioning optimally. With proper care, drivers are ensured safer journeys with lower maintenance costs. Please like and subscribe to the channel. See you next time.